Jaccard Similarity, also called the Jaccard Index, is a metric that measures the overlap between two sets of items. For a concrete example, imagine that you write out a grocery list with items that you wish to purchase. You need an apple, an orange, a tomato, an onion, some spinach, and milk. But when you go to the grocery store, unfortunately, you forget your list at home. You'll likely remember a few of the items you need, but not all of them. You may also see new items at the store that were not on your list, but you decide to purchase anyway. Your final purchases are an apple, some blueberries, spinach, an onion, and a pepper. You can use Jaccard Similarity to score how well your purchases match your grocery list. The Jaccard similarity of two sets is defined as the number of overlapping items found in both sets divided by the total number of unique items in either set. So here, the overlapping items are the items that are on the list that you remembered to buy. There's the apple, the onion, and the spinach. For the total items, we have all 6 items on the grocery list, but we also have to include the items that were purchased but not on the list, the blueberries and the pepper. Overall, that's 3 overlapping items and 8 total items. Jaccard similarity is the ratio of overlapping items to total items. Here, that's 3 over 8, or 0.375. And notice that Jaccard similarity ranges between 0 and 1. That is, we get a 0 if none of the items overlap, and we get a 1 if both sets have the same items. So how can Jaccard similarity be used for real-world applications, besides judging our grocery shopping abilities? Well, we can use Jaccard Index to determine the similarity of two texts. Say that you have the following sentences. Today I need to learn about Jaccard similarity, and later I will need other things to learn. What's the Jaccard similarity in this context? Now Jaccard similarity means the number of overlapping words divided by the total number of unique words in either sentence. There are 4 overlapping words found in both sentences. I need to learn. Meanwhile, there are 12 unique words found in either sentence. So the Jaccard similarity here is 4 over 12, or 0.3 repeating. The Jaccard index can also be applied to judge model performance for binary classification problems in machine learning. Let's say that you have this set of 10 actual target values for some data set, and your model predicts these 10 values. Well, how well did your model do? In other words, how similar are these two sets of numbers? Oftentimes in classification problems, it's most important to correctly identify positive observations, or those with a class label of 1. Jaccard similarity focuses on this positive class. It measures the number of overlapping positives divided by the total number of unique positives in either the actual or predicted set. So let's start with the numerator. There are only 3 examples where we have 1s for both the actual and predicted values. So we only have 3 overlapping positives here. Note that we don't get credit for correctly predicting negatives. For the denominator, now we're looking for any rows that have a 1 in either column. So we're including cases with actual 1s, as well as cases where there were only predicted 1s. Overall, there are 6 total observations like this. So our Jaccard similarity is 3 out of 6, or 0.5. It's also common to talk about the Jaccard index in terms of the confusion matrix. So let's try that for this example. You can convert these actual and predicted values into a confusion matrix grid by tallying up the number of actual versus predicted, negatives and positives, with the actual values across the rows and predicted values in the columns. Jaccard similarity measures the number of true positives, TP, divided by the sum of the true positives, and false negatives. And this is actually an equivalent representation of what we just did to calculate the similarity of these columns. The true positives, which are the rows with overlapping 1s, are found in the lower right corner of our confusion matrix. So we have 3 overlaps. And to compute the denominator, we just sum up all of the observations except the true negatives in the upper left. So 3 plus 2 plus 1 is 6. And we once again find 50% for our Jaccard similarity.